Good day, everyone. I am Angel Faith Latoza from BSEE 3A. Welcome to ECE 37 microprocessor. We are now on Module 8, which is the CPU architecture. So first, let's define what is a CPU. Central Processing Unit. It is the brain of the computers. And in a simplified word, it is the most important part of the computers. It is where all the basic operation takes place. It executes instructions compromising a computer program. Let's take a brief history of the computers. So, ENIAC is the first programmable electronic general purpose digital computer completed in 1945. So, this is its picture. Computers before are gigantic, slow, and fragile. And this man is John von Neumann, pioneered the simplified computer design and architecture. John von Neumann architecture was known because he turned these bigger computers, he designed the smaller one, which can operate the same operations too, the way what these bigger computers can do. So, von Neumann architecture separates the central processing unit from the main memory and the input-output for the faster operations. And on the left side of the picture is the four processes that takes place inside the CPU: the fetch, decode, execute, and write back. So let's talk about the ISA, or the instruction set architecture. ISA is a set of instruction that defines what kind of operations can be performed in hardware, and the implementation of this design is called microarchitecture. So below, the front end and the back end. So the CPU, or the core, splits into two parts, which is this, the front end and the back end. So the front end ensures that there are always enough instruction set for the back end to execute and to avoid delays in waiting for instructions. The front end also predicts what instruction are needed next, fetches them, and decode them into micro operations. So the back end, on the other hand, takes the decoded micro operations provided by the front end. Modern CPU architecture have these features: the superscalar execution and out-of-order execution. So the superscalar execution can execute more than one instruction during a clock cycle. And the other one, out-of-order execution. Out-of-order execution, or more formally called dynamic execution, is most found in high performance CPU to make use of instruction cycles that would otherwise be wasted. So both these features of the modern CPU allows it to operate faster than the older ones. So this is the diagram of the evolution of computers. As we can see, from 1960s to 2015, or the 20th century, bigger computers becomes smaller. Throughout the years, from a massive computer, they have discovered a lot of innovations that can fit all these processing into a smaller one with more complicated instructions. And that's all. Thank you.